Quick review. That Linnaean classification plus one taxon, the top one, domain, is what we still use. Modern classification. Domain, kingdom, file, class, order, family, genus, species. You have your extra credit opportunity that ends at 2:30 today to submit a mnemonic device. I have gotten many excellent ones already. So yeah, if you haven't, give it a shot. Some of them, man, a couple of them I might keep. Binomial nomenclature, really dumb name for that we use the genus and species as the scientific name. There's a specific way to write it. You underline them. If you're handwriting, you italicize if you're typing, and you capitalize the genus and not the species. Questions about that? So we kept the grouping, the organizational scheme that Linnaeus laid down, but the way we actually put things in those groups has changed drastically. It really started with completely physical trait, appearance-based stuff, which of course at this point, it can be really misleading. Just because two living things look alike does not mean that they are related. We know about analogous structures and convergent evolution and even mimicry, right? Where there's bugs that look like birds. There's, things with eye spots that you would think are in the wrong group. And so what we want in modern classification is to use evolutionary relationships to entirely base our classification schemes on who's related to whom, on how long it's been since they had their common ancestor. And while that sounds easy, now that we have things like, cytochrome C as a molecular clock like you did with counting differences, that's great. But even if you can know all that, all of who's most related to whom, there is still the problem of where do you draw those lines? Great, this continuum of who's most related to whom, but where do we separate? Okay, we have a pretty clear line for species. They can breed or they can't breed, but what about genus? What about family? What about order? Where do we draw those lines? Okay, so modern classification is faced with that kind of problem. And what are the answers to it? One of the ways we use to draw lines between classification groups is what we call derived characters. I don't know why they don't use the word characteristics, because that would make more sense to me. But derived characters are characteristics that we consider basically milestones that kind of show up and then don't go away. It's really a judgment call on taxonomists' part, but they're useful. They are a useful way to separate new groups from their ancestors. And to track evolutionary history. And so what you'll be starting to learn today, and we'll keep doing for quite a while, is first of all using derived characters that you're given to sort out evolutionary trees. But then soon after that, to find your own derived characters, to choose derived characters on your own to separate groups from other groups. I promise visual stuff in a second, but let's get some terms down. First of all, once you choose a derived character, and you've got a whole branching family tree where that characteristic is there and present in all of those organisms and all their descendants, that group that possesses that derived character is called a clade. And the diagrams that you draw when you are picking derived characters and creating clades is called a cladogram. That's a type of diagram you're about to start seeing a lot of. And the branch of taxonomy that deals with choosing derived characters and making these branching diagrams is called cladistics. People with shellfish or nut allergies may also be allergic to insects. Says nothing. Keep that in mind. This is impossible to picture without seeing examples. So you're about to see a bunch of examples. For example, if you were going through the evolutionary history of animals and kind of trying to separate out all the major groups of animals and the order they evolved based on the characteristics that have been developed since the first animals, your derived character list might look something like this. Being eukaryotic, of course, that's pre-animals. But for the first animals, the derived character would be being multicellular. And then segmentation, and then jaws, and limbs, and hair, and placenta. Now, that's not all the major animal groups. There's a bunch of stuff in here we're missing. But okay, great. How do we get this information into a form that's meaningful and understandable? Not this. This isn't very good. This just tells us, okay, here are the derived characters. Amoeba is one that's eukaryotic. Sponge adds multicellularity. Earthworm adds segmentation, and so on and so on and so on. I don't like that. Let's draw a picture. Well, here's what a picture looks like. And don't draw it yet, but you're gonna. What we basically do is think of this as, all right, amoeba has this, but that's where it kind of gets off the evolutionary bus. It's not extinct, but it's a direct descendant of one of the first living things that was eukaryotic on Earth. So here's amoeba. It gets this one, right? That's the derived character it gets, but then it gets off the bus and evolves to the present, right? Then multicellularity comes on, that's the sponge. The sponge gets that and kind of stopped there, right? So that's an example of something that just has that derived character. And we keep going, we keep adding derived characters and showing the first animal that we have that just has that, but that derived character sticks around, right? So for example, the salmon has all these derived characters that came before it. They accumulate. It's eukaryotic, it's multicellular, it has a segmentation, and jaws. Does that make sense? You're adding one to the list every time, but the thing right after it stops and sticks with just those derived characters. Here are the things that students get wrong on cladograms. There's basically three. If you get those three down pat, you're good. Number one, students will, instead of putting the derived character before the first organism to have it, they'll put it right on the branch point, which is not helpful because you don't know whether they have it or not, right? It's got to come before the branch point. Number two, they don't have all the organisms make it to the top. They don't make it to the top, like this is time. If they don't make it to the top, they're extinct. So make sure they all make it to the top, unless they're extinct. And finally, the last organism should go not on a branch, but on the main trunk. Good? Draw that. Seems straightforward enough. Think you can take a list of derived characters and make a cladogram out of it? Okay. Well, that's what we're going to do. I'm actually going to give you two different worksheets. Each of them is sort of slightly approaching it from a different angle. Both, I think, fairly simple, except there are going to be two questions that you'll at first kind of lock up on. And I'll tell you what those questions are right now. Because what they're asking you to do is come up with your own derived characters for separating two groups. And here's the two groups. It's going to ask you what are three derived characters that you can pick that separate primates. And remember, that's monkeys of all types, apes of all types, and humans, that separate primates from the rest of the mammals, the furry, warm-blooded, live birth-giving, milk-making vertebrates. So in other words, pick 3 things that primates have that differentiates them as different from the rest of the mammals. Think you can do that? Then take that group and split out humans, right? What are 3 derived characters that separate humans from the rest of the primates? Those are really the only 2 kind of challenging questions, okay? But understand that this is not something you're going to be able to look up. You're going to have to come up with them on your own. And there's tons and tons of right answers to this, but there's also wrong answers. They have to be real derived characters that do differentiate us from primates or primates from males. Good? All right, that will all be due Monday. Turn this on.